Today's video is on lesson 3.7, perpendicular lines in the coordinate plane. In our last video, we learned about parallel lines in the coordinate plane and what happens with their slopes. So this is similar but a little bit different. So in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Basically what that means is that the slopes have to be opposite reciprocals of each other. So last year in algebra, when you studied linear equations and you graphed all those linear equations, the perpendicular lines had slopes that were opposite reciprocals of each other. And so that's what this theorem is telling us. And actually it's a biconditional statement. Now it does specify that they have to be non-vertical lines because a vertical line has an undefined slope. So we can't identify the slope because it's undefined. So then we do say that vertical and horizontal lines are perpendicular to each other because vertical lines have an undefined slope and horizontal lines have a slope of 0. So those two are opposites of each other, but their product is not -1. So to determine if lines are perpendicular, the slopes have to be opposite reciprocals. So for example, -3 and +1/3 are opposite reciprocals of each other. We could also have -5/2 and +2/5. Those are opposite reciprocals of each other. So is 9/8 and -8/9. Those are opposite reciprocals. So lines that would have those slopes would be perpendicular to each other. So we're going to look at a couple examples. Here, our first example, we know that line M goes through -3, 3, and 5, 2, and line N goes through -1, -4, and 0, 1. So I want to know, are those lines perpendicular, or do their slopes, are they opposite reciprocals of each other? So you have to calculate the slope and then find out if they're opposite reciprocals. Now we can do something similar when we have the equation of two lines. The first line here, we have y equals -2/3 x minus 1. In our second equation, y equals -3/2 x plus 1. Now, if you remember back to last year when graphing linear equations, that the variable or the coefficient of the x is your slope. So for the first equation, -2/3 is my slope of that line. And in the second equation, -3/2 is the slope. So are those two numbers opposite reciprocals of each other? It doesn't matter what their y-intercept is, it's just the slope that has to be opposite reciprocals. So are those two lines perpendicular? Question number 3, are these two lines perpendicular to each other? And so now you have to solve for y. So you have to use some algebra, get y all by itself, and find out if the coefficients of x are opposite reciprocals of each other. So I'd like you to do problem number 3 on your own. Solve both equations for y, and then see if their slopes are opposite reciprocals. And then our fourth and final example, line R has an equation, y equals 3x minus 2. Find the equation of the line that passes through the point 3, 4 and is perpendicular to R. So remember, the equation of a line is y equals mx plus b. Y is a y-coordinate, so here we have 3, 4. So in place of y, we would put the number 4. The slope has to be the opposite reciprocal of +3 in order for it to be perpendicular. So figure out what that slope would be. You're going to put that letter or that number in place of m. X is the x-coordinate of this ordered pair, which is +3. So you're going to put in 4 for y, the opposite reciprocal of this 3 for m, and put in this 3 here for x. And you're going to substitute all that in and then solve for b. And then once we find out what b is, we're going to use the slope that we used in this equation, which is the opposite reciprocal of this up here, plus our y-intercept that we find, and we're going to rewrite it in this form, y equals mx plus b, but in place of m, we're going to have the slope, and in place of b, we're going to have the y-intercept. Hopefully that makes sense. It's something you did last year with algebra. I know that you did a lot of it last year. So hopefully that makes sense. Now we're looking at it from a geometric standpoint. So have those 4 questions done for class tomorrow. and have a good night.